Okay, hi and welcome to your very first section of video notes. This one we're most likely going to do in class so that you can kind of get the hang of it. But after this will be probably second nature to you and you'll be doing it nightly. So, we'll usually open like that. I'll kind of tell you what the main point of the notes are. And if you look here, we're going to be building our mathematic vocabulary. This should be a review. These are terms that you will be familiar with, but we're going to go ahead and go over them again just so that we're kind of clear. So what I want you to do is first, before we begin, ask yourself, what do you think a variable is? Now I know you can probably look it up, find a nice definition, but realistically, the best way to do this is to make an attachment to what we know. So what I want you to do is go ahead and pause the video here and ask yourself two questions. Let me grab my pen here. The first question I want you to ask yourself is, what is a variable? And the second question I want you to ask yourself is, what is it necessary for? Go ahead and pull up what you know, pause the video right now, and then we'll come back and talk about it. Okay, so you had a minute to think about it. Here are some things that I've seen people answer to those questions before. What is a variable? An unknown that usually comes up. Definitely something that changes is usually kind of the concept there. It's varying, right? It's never the same, or it can be different. We can make it one thing and then make it something else. Usually represented by a letter or some type of a symbol. Those should be things that maybe you came up with there when you paused the video. What's it necessary for? Finding unknowns. So usually we don't know what it is, but it helps us find that thing that we're looking for. Usually involved with some form of solving. Right? So those should be the general terms so you have an idea of what a variable is. But let's get down to what the book defines a variable as, just so we can kind of have a concrete way to talk about it. So it says that a variable is a symbol, usually a letter, we said that hopefully, that represents one or more numbers. It can be lots of things. Sometimes we solve it for one, sometimes we want to change it so that we can see what different results come out of it, different outputs that come out of it. So here's an example of what you would use a variable for. How many hours are you going to study tonight? Maybe a half hour, maybe an hour, maybe 2 hours, just depends, right? But really what we want to do is, because it's different for each person and it's different from night to night, it's different for each subject, we'd probably want to give it a variable for whatever specific situation we're talking about, because it's not always a half hour, it's not always 1 hour, so we're going to give it some variable. Now, when you assign a variable, it's useful to go ahead and do that with the letter that may help decide what it actually is. So in this case, I would probably choose H to represent hours of study. Okay, I could choose X. I could choose Y. There's reasons to choose X and Y, and we're more familiar with X and Y, and we'll get into why we use those quite a bit. But for now, I would probably choose H for that. And you can see the number 2 we did. It says, how fast did you drive home? I'd probably choose R for rate of travel. Some of you might choose S for speed. In math, in science, we tend to use R as a rate versus a speed there. But either one of those would be perfectly fine to use. Let's go ahead and keep building on some basic vocabulary so that we can kind of talk about things as we move along here, as we get a little more specific. An algebraic expression then is a mathematical phrase that can include numbers, variables, and operations. So it can include 3 parts to it. Notice that numbers was followed by the word constants. We're going to use that word. So if I say constants, that means numbers, right? They're going to be back and forth the same thing. Really what that means is that I can add an x, I can have an operation, and I can have a variable. That's a mathematical expression. Notice that I did not have an an equal sign in there, which would make it an equation. That would be our next definition. So this is just an expression, meaning that I can plug something in there and whatever number it happens to be, let's say I plug in 4 plus 2. It's great. It's an expression. It does have something that it equals, and if we add an equal sign, then it becomes an equation. Then it becomes something very specific, right? So that's what an equation is. It's a mathematical sentence or expression that has an equal sign, okay? If the equation is true, right, then the 2 expressions on either side of the equal sign represent the same value, meaning that they will end up being the same thing. So if we take our expression from before, x plus 2, we had an equal sign. Let's pick a number for the other side of the equal sign. Let's pick a number of 4. If it's true, the value that I plug in for x will make this left side here the same as the right side. If it's false, then it will not. So let's go ahead and make one that's true here. So I'm going to go ahead and add in 2. So it'd be 2 plus 2 equals 4. 2 plus 2 we know is 4, and so 4 equals 4. That's true. That's generally what we're looking for when we solve things in algebra or working with expressions or equations in algebra. We like to find out what this unknown is, and that's essentially what we just did. We said, hey, we know that x has to be 2 to make this expression true. If x was 3, let's say, we know that that would make it 5. So 5 would not be the value of x. Or I'm not 5, but I mean 3 would not be the value of x because it makes the result 5 equals 4, and that's a not true statement. But that's kind of what we do there. Okay, so if an equation contains more than one variable, we call those open sentences. We'll work with those. We won't use the terminology open sentence a lot, but just so that you see it, that you're familiar with it. That would mean something like x plus y equals 3. That's a little harder to solve right now. We actually couldn't solve this one because we don't have enough information. So we'll save that after we get comfortable with our variables and our algebraic expressions and our equations. Maybe we'll start talking a little bit more about open sentences. Okay. A little side note here. In everyday language, the word is often suggests equal sign. Go ahead and put that in your memory. That's very useful, especially for the part where we translate words into expressions or equations. It helps us identify what piece that actually is talking about. So let's see a couple quick examples. Algebraic expressions. There's an old note there. I didn't make that change. 2x plus or minus 5, or 2 times 4a plus 7b. These we would refer to as all expressions. Okay, no equal signs there. The variable in these cases can be anything. I can plug any value for x because it's not equal to anything. So it can just continually change. However, as soon as we add an equal sign, like these equations over here, x becomes something very specific. And you'll notice this one is a very awkward one to do. So let's just go ahead and change that 2 to a 3. Makes it a little easier to work with. Now you can figure out what x has to be, right? X has to be 5. 5 times 3 is 15. Minus 5 gives us 10. So the only way for this equation to be true, it's only true at one spot, right, is if x is 5. That's the only place that it's true. And again, what we did there is we solved to find out our unknown, which we said previously, right? That was one of the things that we said. We like to help find unknowns. That's what it's necessary for, through solving. All right, so we're almost done. Here's the reverse of what we did. We've been working with the expressions and with the equations. Now we're going to take our words and translate them in, because sometimes that's what we have to do, and that can be some of the hardest part. So it says write an algebraic expression or equation for each of the following phrases. What I like to do is put on the actual value or number or operation that it is on top of the words as I go, and it kind of writes itself. So I'm going to go ahead and write a 7 here because it's 7 more than n. Well, more than is a term for addition. You can memorize that if you want. Most of us probably know that, and then n is there. So the expression that I'm quite literally am trying to write is 7 plus n. See, it writes itself. It's kind of nice. The product, most people know that the product means multiplication of 7 and n, right? So I need to have a multiplication. It's not between them, but so what? I know that that means 7 times n, or 7n. Here's another one. 7 is less than 3 times a number. So 7 is less than. So we have to be careful with subtraction, right? We know less than and equals subtraction. That's what we're talking about there. And you're like, wait, is it an inequality? No, that's not really where we're at yet. So we need to make sure that we pay attention to subtraction, because it has an order to it. Order actually matters. But we can finish this off and see if we can get it right here. It says 3 times a number. Well, we know we're going to take 3. There's our multiplication as in times, and then a number. I get to pick what that is. I'm going to go ahead and say n for a number. So 7 is less than 3 times a number. So do we write 7 minus 3n? Or do we write 3n minus 7? 7 is less than 3 times a number. So that would be representation of what we wanted to see there. All right, you can see a couple other examples here. If there's anything else that we want to do, I want to try to keep this video as short as possible. So we'll finish this up in class, and you'll actually do one on your own next. All right, thanks for watching. We'll see you in a second.